It's Monday, March 31st. I'm Scott.
I'm Rim.
And this is Geeknights. Tonight, more on programming languages. Let's do this.
This past weekend was the Night of Iron.
It's really more like the nothing weekend.
Yeah, but it was the weekend that also included the Night of Iron. On Saturday night, we had nothing better to do, and we had free time, and all our work was done. So, we had the Night of Iron.
It was indeed a night of much metal.
And it was a very good kind of metal. Notice I'm not saying what it was, and that's because I kind of want to keep you all in suspense, because nothing called Night of Iron could not be awesome.
Yeah, we didn't plan the Night of Iron, and we were like, hey, why don't we do this? And we're like, hey, that would be the Night of Iron, wouldn't it?
And of course, then we had no choice. The path before us had been prepared.
Yeah.
That's all I got. The weekend was relaxing. I went to work today.
Yeah. Oh, I remember. I have an opening bit. I remember what it was.
You spent like 5 minutes before the show going, oh man, I wanted to say something, but I forgot it. Screw it. And now you remember it?
I remember it. I knew I would remember it real soon, and I did.
All right. So what do you got?
So when I worked in the city the last time, which is the first job I got out of college that wasn't a co-op, right?
Yes.
I worked over near where Emily and Alex work now, right? And that building had a scaffold on it.
Is that scaffold finally gone?
Well, no, that scaffold, while I was still working there, they removed it, right, at some point.
Is it back?
No.
Did it fall on someone?
No. Then that same company moved me to the middle of nowhere, and then I quit that company, and I came to work for the company I'm working at now. The building that I'm working at now had a scaffold on it. Until today, they removed the scaffold.
I think that means that you're going to get a new job.
I think it means that I will only be hired by companies in New York that have scaffolds around the building.
Well, you know,
eventually that scaffold will be removed from the building.
By that logic, because I have a similar logic, every time I get a job, I walk from Yonkers Station up to, from Yonkers Station up to kind of the northern part of Yonkers.
Uh-huh.
And then I take the number 6 bus.
All right.
So, yeah, call Randy.
Okay.
So, yeah, that's all we got.
That's it.
Woo!
Scaffolds on buildings. It's pretty freaky when they take them off, because that scaffold must have been there so long, because all the stores, they don't have big signs saying what they are. These big flat areas. So all those stores are probably going to be calling up the sign makers.
Well, actually, funnily enough, I went to dinner, a ramen joint with Emily on Friday. Just kind of out of the blue, like, hey, want to go to dinner? Yeah. So we went out, and we're walking through near Astor Place, because there's an awesome video game store there.
Yep.
And then she says, hey, look where we are. Remember this? And I'm like, I look around and I don't recognize anything. Like I look and it's like, wow, I've probably never been on this street before. And it turns out, no, she used to live on that street. The scaffold was just gone.
Yep.
And it looked like a different street.
Yep.
But that reminded me of something that happened.
Mm-hmm.
Before I met her, I got out of work. I get out
of work. You got killed by a scaffold?
Yes, I'm in fact dead.
Oh. Okay.
This is a computer-generated rim.
A scaffold ate your mom?
Much like how they finished that John Candy movie without John Candy.
And now you must seek scaffold revenge?
Actually, that leads to even, God, talk about the non sequitur train going off to nowhere. Well, actually, no, it's the sequitur train. It's not a non sequitur at all. When John Candy died, the
fat guy was killed by a scaffold?
And when Princess Di, when both of them died, were two instances where I was able to prove to my parents, astoundingly, that the internet was powerful, because they never believed me and they always kind of scoffed at, like, whatever. And then I remember one day I was like, hey, John Candy's dead. And they were like, what? That's BS. There's no way. And then the next day, the news was like...
there's no way that a big, fat, unhealthy guy died. Okay.
No, there's no way. How would you have found out about that? I was like, the internet said so. And then when Princess Di, I was in the realm playing, and then someone named Princess Di said, out of the blue, man, I'm going to get a lot of shit for this name. Because he'd been called that for like 2 years. And I'm like, what? And he's like, well, and he says what happened, and then we're all like, oh, yeah, that sucks.
Change your name, dude.
No, he was like level 80. You couldn't change your name.
I wonder, can you change your name in the World of Warcraft?
You just make an alt and power level it.
I know, but I mean, like, if I level up to like the highest level in World of Warcraft, but my name suddenly becomes taboo, can I change it?
Yes, by making an alt and power leveling it.
Yeah.
Man, that's the thing. All you kids now, you're so lucky. There was no such thing as power leveling in the realm.
Well,
You
there was.
killed-
I think, back in the day there was power leveling, but you know what they did? They would fucking notice you doing it and kick your ass and kick you out.
No. Back in the day, once you got a high enough level, you'd get like 1 experience point for killing the biggest, baddest thing in the land. You'd have to go and kill it 1,000 times to level up. There was no way around that. A higher level character couldn't get you more experience.
All right. Anyway, can we move on to news and things of the day?
But I didn't tell my story. Because don't worry, I don't have a lot to say about my news. So, aside from John Candy dying, I was waiting in the Starbucks at Astor Place. Not the scary hobo Starbucks, the other Starbucks, the nice one.
Oh, this story. Okay.
And this is just weird and funny. And it's probably bad because I'm sure it stroked my ego just a little bit. But at the same time, it is kind of weird, just funny.
I think your ego, it's kind of hard for anyone to stroke it because basically you have these auto strokers that are covering every inch of it.
You know what?
And the surface area is, even though the surface area is constantly increasing, the auto strokers sort of spawn new strokers.
I think the real issue with my ego is that, well, actually, it's much related to tomorrow's thing of the day. Anyway.
Yeah.
So I'm sitting in the Starbucks. And Emily calls me. She says she's going to be a little bit late. And that's fine. I got my laptop. I'm working on stuff. And I'm just chilling there. And a few minutes later, this guy, and he's pretty cool looking, 20-something guy, and he walks up behind me and he says, "Excuse me, sir." And I'm like, "Yes." I turn around. "Are you," a long pregnant pause, "Are you Rim from Geeknights?" And I'm like, "Yes." "Oh my God, I can't believe it's you. I heard your voice, but I wasn't sure where. I had to look a picture of you up online and make sure it was you. Oh my God, my girlfriend's going to be so jealous because she's not here, but oh my God." And the fact that I've been recognized by a fan randomly in New York City, as opposed to randomly at, say, an anime convention I've been to for the last 5 years, is somewhat startling and bad for my ego not getting any smaller.
Well, I mean, on the one hand, it's sort of likely. I mean, in a crowded city with a lot of people, if you have a few thousand fans around the world, and we're pretty much limited to the English-speaking world, odds of fans being in New York City pretty good. Odds of fans being in a part of New York City where people our age tend to be a little bit better. It's really, you met a fan in public in one of the most likely places for there to be a fan in public.
I don't think one of the most likely places. That'd be like a GameStop.
Yeah, but you know what I'm saying. It's like, it's pretty close. It's pretty high on the charts of likely place to meet a Geeknights fan in public.
Yeah, but even then, I think the odds
It's not like you met a Geeknights fan on a cornfield in Kansas.
That might be more likely, because odds are, if I was going to a cornfield in Kansas, on the show, I'd be like, "I'm going to be in this stupid cornfield next week. If anyone lives there, please come say hi."
Please give me some corn. No, wait, no, I mean...
The opposite of
the
that.
The opposite of corn. I'll have too much of corn. I need more of everything else.
But no, I think it illustrates something much more important. People recognize us not by sight, but by sound. Now think of that. Sitting there, doing your thing, and suddenly...
Well, when we redo our website, we'll go get pictures taken of us, and we'll have pictures there, so people will recognize us by sight. And we'll also start doing videos or something.
But the fact that you could be sitting somewhere, and then you hear my voice, and it's like, I don't know where that voice came from, but I know what it was.
Yep.
So yeah, dude, I forget your name, but I think I saw that you emailed me. You're totally cool.
Well, I think his girlfriend emailed us.
No, he also emailed us like a little while ago. I haven't read it yet.
Oh, okay, whatever.
Because I'm doing this podcast thing instead.
Anyway.
So, and speaking of podcasts, what do you got in the news?
Okay, so Motorola. Motorola is a company. Motorola makes a lot more things than you realize they make. I mean, before the Macs had like IBM Power PCs in them, now all the Macs had Motorola CPUs in them. Motorola makes a lot of chips. They make a lot of things in general. You probably have Motorola products in your house you don't even know about. The Motorola products in your house that you do know about, though, are usually probably cell phones and that sort of thing. And, for a long time, Motorola actually was a pretty badass cell phone maker. I mean, that StarTAC, I had one. That was one of the best phones. It was like the first phone that was kind of thin, And then they made the Razr, which is like, it's a huge hit, right? Crazy huge. But you don't really realize it these days, but Motorola's kind of in the shitter. not doing so well.
Yeah, they've had a lot of trouble lately in the stocks and such.
And one of the things I realized, from reading this and reading other things, is that business-wise, part of the reason they're doing bad is not only because they haven't come up with anything new, but I'll get to that, but because the Razr, right? When the Razr first came out, it was sort of like Apple's products. It was a super sexy, high-profile device that people desired because it was so ludicrously thin, right? But unlike Apple, where Apple will up the marketing, up the price, and make it, oh, it is so great, Motorola started out that way. The Razr was like $200 and like this ultra fancy thing only for, cool people.
But then, not too long later, Rim, Captain, gets the cheapest crap cell phone that he can get free from whoever he gets cell phones from, goes to get a cell phone, and they're like, here's a Razr.
Yeah, now they have it in like every freaking color. It's the free phone that you get. It's like, so it's really, doing that. On the one hand, it's sort of like, well, you make a lot of money because now you sell a bajillion Razrs. But on the other hand, you don't make so much money and keep your company afloat because you're not having the cool, awesome products. But now, as for not coming up with anything else, some guy. He's not just some guy, actually. He's Numair Faraz. I probably pronounced his name wrong. Sorry, Numair Faraz. He was the personal advisor to Jeffrey Frost. Jeffrey Frost was Motorola's former CMO. That's the guy who pretty much invented the Razr, right? And then worked on the Rocker, and he was pretty much the guy at Motorola who made and pretty much came up with all their shit that was worth a damn. And without that guy, they're fucked. And, well, that guy died in 2005. And it's pretty sad because, there's no evidence of this, but if you read the story, like if this was like a play on Broadway, the guy was worked to death. The company and all the executives pretty much work this guy to death, having him come up with all the new stuff.
But regardless, that's a separate issue.
That's a separate issue.
Though, granted, this guy had a high truck factor.
He had the highest truck factor, because now without him, Motorola's in the shitter. And his personal advisor, Numair Faraz, wrote a letter to Engadget. Well, he wrote a letter to Greg Brown and the rest of the executive team at Motorola, pretty much calling them out. Like, wow, you guys suck. You've ruined Motorola, which is a great company, blah, blah, blah. And this is really a fascinating read, because he sent the letter to Engadget to be posted on Engadget, which... There's a guy, Jason Calacanis, who used to be in charge of Weblogs Incorporated, which is a division of AOL, and Engadget's a division of that, and he's now doing something else. But on Twit, he talked about how the way Engadget is so awesome is that all these people who work at these big tech companies are like friends with the Engadget guys, and they'll use Engadget as a bludgeon against their own companies. Like, so some guy working at a company, like, say, Apple, right? If Apple does something they don't like, they'll leak it to Engadget. Engadget will say it and then force Apple, to change its ways or whatever.
Granted, if I were Apple, what I would do is internal to the company, I'd periodically...
I would just block Engadget.com.
No, I'd make it appear that things were going to happen to select groups of employees that weren't going to happen, but that were bad, and see what got leaked. And then, of course, I can look good by being, no, that's totally untrue and made up, and discredit all these people. But then I could slowly figure out who's leaking and either get rid of them or get rid of them.
The side effect of that, though, is that all these really bad stories about your company will get out.
See, but then all those really bad stories immediately get refuted and never come to pass.
That doesn't help. It doesn't, that might, that's true, but the mind share is still, you're putting negative mind share even if the reputation doesn't erase that.
Only in the immediate short term. If you do it once, yes. If you do it twice, yes. If you do it 40 times, then suddenly no one trusts any bad news about your company. And then when it finds out that you're actually dumping radioactive waste inside of baby seals for fun, no one cares because that's just fake, like all those other fake stories.
Anyway, the point is a really fascinating news story, and it's kind of sad because, like, wow, Motorola was, they made good phones, and now what's going on? The company is splitting in half. One half of the phone part of the company is going one way, and all the other stuff that's actually profitable and still, business as usual chips and stuff is going to the other part of the company.
Now, I'm not allowed to really talk about my opinions on the future of Motorola, but I think I can say it pretty obliquely by saying that I will probably never see in my hands a new Motorola cell phone.
No, it's really fascinating reading all this stuff this guy says, because he talks about how, like, why does Motorola have like this fleet of private jets where other companies the same size maybe have one or two, and it's like, why, are the executives like don't even know how to use a computer? He has, emails printed out and put on his desk, and he basically just bashes all the CEOs and boards and all the high up executives in the company for being completely incompetent and not knowing anything. And he talks about how the guy who died was pretty much the only reason that their phones are ever successful. And
wow,
it's a pretty sad story.
That it is
in general, and it's really worth reading if you care about the insides of tech companies and how the tech industry works and whatnot.
So speaking of one person who's awesome, I want to talk about this a little bit because the story itself is not super important. This is like news from nowhere that no one will really care about, but the lessons learned from this are pretty impressive and important.
Is the damage irreversible?
Man, that comic hasn't updated in like ever.
But those guys are still doing stuff. They did something for Penny Arcade recently.
But they don't do anything for me.
No, they don't.
In fact, I remember...
I bet you if you paid them, they'd do something for you.
No, they didn't. Remember? I ordered from them a big poster, and for like 5 months, it never came. So finally, I went to Mocha, and they were there, and I was like, I ordered a poster. Where is it? And they were like, would you like one now?
Yeah.
And I was like, yes. Yes, I do.
If they're at Mocha again, you can get on their case.
Oh, well, anyway. So, basically, the story here is that some school that had a computer network was so incompetently managed, like pretty much every school I've ever seen is in terms of
pretty much
IT.
every public school in the U.S. and most of the private schools and
Yeah,
pretty much most schools.
Yeah. But,
well, there's a town somewhere where the town has like a team of like 3 IT guys who are super Linuxy, so the whole town is perfect. But anywhere else is probably terrible.
Anyway, so basically what happened is this 11-year-old kid who knew a little bit more about computers than everyone else at this school, including the teachers, everyone, basically said, I'll fix it, and now he's the network admin.
Well, after the IT guy just left, basically was just like, screw this school, and he was a terrible IT guy, apparently. The librarian who sort of, because the librarian has to deal with, like library computers and whatnot. So I remember in elementary school, our librarian was sort of more, the computers than anyone else because he's sort of forced to learn that sort of thing a little bit. So his mom was a librarian, which is why, he sort of got into that, gig there.
Now, the kid didn't
get it inside.
The kid didn't do a perfect job, but he proved something very important because basically all he did was the smart thing that anyone with even basic like technological computer literacy, not straight up computer literacy, but like kind of power user computer literacy would do. He port scanned the network, ping scan, figured out what all the devices were, got rid of all the spyware and malware, put some antivirus and some, gateways and things, and basically just cleaned everything up and upgraded everything.
Yeah, he just, went around doing Windows Update and all that. He's not actually doing the good, amazing job that someone like us would do, but what he's doing with basic knowledge of things, he's basically doing to every computer in the school what you should do to your computer in your house, and it's making the school 1,000 times better than every other school, even though it's still not good on the absolute Scott scale.
Now, this speaks both of hope and of fear. It speaks of hope because it is proving to me that, yes, the generations that are coming up, despite the fact that things are a lot easier for them than they were for us, and then things are a lot easier for us than they were for the people before us, there are still punk kids out there who know what they're doing.
Yep, they're still learning the technology, because, there are some people who have said that, hey, because you weren't forced to use computers when computers were hard to use, you don't actually learn anything, and it sort of seemed that way. It seemed like people who were younger than us, they knew how to use a computer for Facebook or whatever, but they didn't really know because they didn't have to deal with installing PC games in DOS.
But then at the same time,
writing in BASIC on an Apple II.
Yes, a lot of people from that generation, they only know how to use Facebook. But the similar percentage of people from the previous generation couldn't have used a computer at all, even if they were like, and I think the same percentage of kids are awesome and techie regardless of how easy it is.
It's beginning to seem that way from
They just,
our
in fact, if
anecdotal
anything,
evidences.
they have the benefit that they can stand on the shoulders of giants and skip all the. They don't have to learn about IRQs. They can jump straight into writing a Python program.
Yep.
But it also speaks of fear because the fact that this school did not have any competent technological person at all, not a single person knew enough about computers to be able to do a better job than an 11-year-old.
Yeah, I mean, I would do it. Hire me, but they probably can't afford me, so it's not going to happen.
They're not going to pay me six figures.
No, they're not, which is what it would take for me to be. I would be the IT guy and the computer teacher at the high school for an entire school district. But you'd have to pay me $100,000 a year because that would be like,
I'd probably be willing to do it for a lot less.
That would be a great job.
But even then,
it would still be like $80,000. They wouldn't pay me that. I'd be getting more than any teacher.
Yeah, that's really the sad thing.
Because really, I'd be doing two jobs, teacher job and IT guy job. That's got to take a lot of monies.
I think the real problem is just that there's no... The way IT and CS and computer things work, if you're competent at all, you can always make a ton of money out in the real world and not working for schools. Not just schools, but other things too. I mean, most hospitals have awful IT. It's part of the reason why I left my previous company.
Yeah. But yeah, IT is so bad that 11-year-old kids can do a better job. Even when the job they do is terrible, it's still a better job than real people.
Thing is, though, he didn't do a terrible job. He did probably the same job I would have done when I was 11. I mean, God.
When I was 11...
When you were 11, Scott.
Well, when I was 11, they didn't have Windows, but...
But even if they did, think about in middle school what you knew about computers. You could do a middle school job probably.
Yeah, realistically, my school didn't really do such a bad job. The bad job they did was, there were a few obvious security problems, which I could have patched up that they didn't. But other than that, the main problem was their bad policy rather than their bad systems.
I remember when they caught me in hacking the computer. Hacking the computer meant...
Was installing Shockwave Flash?
Not even that. Hacking the computer was I rebooted, and then I held F5, so I was in DOS, and then I was writing a program in QBasic to make sounds. And I was bored, and they accused me of hacking. And I was like, can you even explain what I'm doing?
Mm-hmm.
And they really couldn't. And they were like, if you weren't an honors student, you would have been suspended. I was like, whatever.
Yeah, okay. Yeah.
But anyway, things of the day. I'll warn you, I think this thing of the day is awesome. However, some of you might think that it is boring. What I have to say to you who think it is boring, I don't know, I could make fun of you. I don't know what I would say. I'll just warn you that you might not find this terribly interesting, but at the same time, you might find this fascinating. This is a 20-minute explanation of how to manipulate three-dimensional and two-dimensional shapes in terms of inversion. And that might sound weird, but trust me, if nothing else, watch the first 5 minutes because they'll explain what they're talking about, and then they'll ask a question. You'll think, oh, I'll just do it this way. And they'll say, oh, well, here's why that doesn't work. And they show you with this little diagram. And then they'll show you the answer, and the answer is crazy. Now, if after seeing the answer...
That's someone's like Nobel Prize, or not Nobel Prize level, but that's like master's, doctorate, thesis math answer there.
In terms of
some guy figured that out
and describing kind of like three-dimensional geometry and math, like I'm trying to use words that will make this make sense.
This is the kind of stuff that we don't even really understand, so it's not easy to talk about it.
Well, I mean, I remember doing a lot of stuff with three-dimensional surfaces and calculus.
I mean, I understand it on a surface level. I could not reproduce.
Was that it? Was that a joke, or was that just a mistake?
It was sort of a joke. I could not reproduce it, nor could I explain it very well.
I mean, the furthest I got was like, all right, calculate the charge distribution on a three-dimensional surface. And if that sounds scary, it's even scarier when you find out that the answer is double integrals.
Yep.
Double integrals suck my balls.
Single integrals sometimes suck my balls, so two is just more ball sucking.
The thing is, a double integral
sucks the whole sack.
Isn't even so simple as two integrals. It's something far worse.
I know.
But anyway, this video is amazing because this is the way to teach things like this because it's kind of a question and answer. You've got the instructor who knows the answer asking the leading questions, and the person who doesn't know the answer asking questions. And they're kind of being guided toward discovering the answer on their own without being given the answer.
Yeah, it's sort of like the very beginning of the video, which is all I've seen, is basically anyone can understand what's going on. It's very visual. It's very obvious. And it really, if you're the kind of person who is a problem-solving, thinking person, you're going to look at this and you're going to be like, huh. And the guy is thinking the same thing you're thinking. It's like, huh.
I showed Scott a little bit, and he's like, duh, I do this. And then the video is like, duh, I'll do this. Oh, it didn't work. Shit.
And I'm like, no, it's bullshit. It would have worked, but I was wrong.
They're like, no, here's why it wouldn't work.
Like, and then eventually they're like, here's the right answer. And the right answer is so crazy that you want to watch the rest, which is probably would have been boring on its own, except it's explaining the thing that was so crazy that blew you away.
Yes, and seriously, it's worth watching just to see the crazy thing. You'll know it when you see it. It's crazy. The answer, it's like, the answer is probably going to be
Imagine if there's like a
complicated.
simple math problem, right? But you couldn't really figure out the answer, but it didn't seem too complicated. You
It's
know?
like adding, like they ask you questions, like add a bunch of single-digit numbers together. And you're like, all
and you're
right.
like, and it's a little tricky, maybe, but you're sort of getting at it.
And then
know?
you're like, what's the
like
answer?
You have the ability to think about the problem, but you can't arrive at the answer because every answer you come up with is wrong. And then you're just like, oh yeah, the answer is absolutely insane. You're
It's like
what
add
the
a bunch
fuck?
of single-digit numbers and then multiply it by like 1.1 and blah, blah, blah. And you're like, all right. What's the answer? It's like 10 billion. Like, what? 10 billion.
Anyway, can I do my thing today?
This is super cool.
All right, so check out. This is way cool dude, and he's doing some raps. Now, usually raps about things that are, are so often corny. This one is a little bit corny, but
This is terribly corny.
it's not terribly corny.
It is terribly corny.
It's kinda
awesome,
corny.
but it's terribly corny.
It's kind of corny. This dude does a rap. He's pretty good at the rapping. I would say slightly above average rapping skills. But his rap is about web design. And this guy really knows about web design. And if you know about web design, this rap will entertain you greatly because it's pretty much just inside, basically, guide to web design.
Don't get turned off by the very beginning. It might be like, oh, this is going to be lame. He goes into some depth.
Yeah, it's like we're talking minutia. We're usually you hear one of these raps and it's like they sort of talk about something.
It's like, I
they'll
got the
discuss a
H
topic, but obviously they only have some sort of surface layman's knowledge of the topic. And you're
Like a lot of those like people who they say they're nerdcore and they try to make some nerdcore, but all they really do is say Dungeons and Dragons twice.
yeah, exactly. This guy really knows his shit. I imagine he's a web designer and a rapper. And if you're a web designer, you will find this very amusing.
And if you are a rapper, I hope you find this amusing.
Yeah, if you're a rapper, you could probably find a better rap. But this rap is not bad. It's much better rap than expected. You expect like a really bad rap for this kind of thing. But no, it's an okay rap. This guy gets mad points.
So moving right along, we've been doing this alternating ITCS thing for a while. We're going to do one more set of them, and then we're going to go back to kind of our normal Monday shows for a while.
Oh, wait, CS Day? Shit.
Yeah.
Oh, wait.
I guess I could talk about IT.
No, I'm just kidding.
Because I just dropped 50 grand on a stupid ticketing system, and now I got to fly away for like a week to learn how to use it.
No, I'm just kidding. I'm messing with you. I was trying to be all like, oh, shit, wait. To make people, I ruined it. Anyway. I got to talk about some CSs today, I guess, right?
Yeah, now last week I think you talked about programming.
Last week I did a terrible job.
Well, last time, not last week.
Last time.
We realized that Scott and I are alternating the mech because Scott did an awesome intro to IT, and I was like,
CS?
CS, yes. And then it was like my turn to intro IT, but I was hungry and we had Brawl, so I was kind of like, yeah, IT is everything. And that was the end. And then I did a really good one, and then we're alternating here. So it's Scott's turn to do an awesome one.
Yep. All right, so I'm going to try to do an awesome one. I realized that this sort of like trying to do these episodes, I have to find a balance because on the one hand, it's like I want to give all the information. Like I want to give the whole thing from beginning to end, not jumping over any steps.
In the beginning, there were only zeros.
I want to step on every single stone to get across the river. But I realized some of those stones, like the stone I did last time, not so interesting and not so useful to the people.
Yeah, I mean, think about it. Most of you...
Even though it is an important thing to learn.
Most of you out there, a lot of the questions we're getting, people are like, so what programming language does what? Which programming language should I learn? Is Python cool? What about Ruby? And to answer that question, Scott really had to talk about, well, what is programming?
Yes.
But all those people were going, okay, but what about Ruby?
Yeah. So I'm going to have to find a way to strike a balance between the things you need to know and also the things you want to know and being entertaining. And I think I can do this, right? So last time I talked about, what a language is. Now it's a set of rules for arranging an alphabet, in a way. And, the thing is you can make up any language you want, right? So why do we have a whole bunch of different programming languages? Because each language, the set of rules you come up with, is made in such a way so that you can match, the goal is to match human thinking with the assembly language in the computer. So
I'm glad you didn't say computer thinking.
Computer thinking. You want to find a language, because a programming language can't be a human language, because a digital, non-fuzzy logic computer cannot understand it, right? If it could be a human language when we develop some amazing AI...
Computer, write me a Perl compiler, and then write me a Perl program and compile it in it.
Exactly. We won't need programmers anymore. All you'll do is you'll tell your computer what you want to do, and since your computer is an AI that just happens to also be connected to some, really powerful processing...
But also at the same time connected to some sort of schoolgirl prosthetic.
All right.
You know what's going to happen in the future.
Yep. Then you won't need a programming language anymore. But because we still need a programming language, what we do is we come up with rules for arranging alphabets, some grammars, to design languages in such a way that a human can think in those languages and work with them. The same way you think in English, you can think in C or think in Perl or think in Python. But also the computer can read those languages and actually do something based on those languages, convert them into computer instructions. So the reason we have different languages and not just one language that's perfect is because what you're doing with a language is you're trying to solve a problem, all right? You might be trying to solve the problem of when people visit my website, send them a page. You might be trying to solve the problem of do complex math on a supercomputer. You might be trying to solve the problem of make my calculator do normal math. There's all these different problems. And when there's different problems, it's easier to think about certain problems in certain ways. And since you can't sort of write one language to rule them all, which I guess would be sort of crazy, right? We create languages that are structured in different ways so that they are suited to solving certain kinds of problems. For example, Lisp, as in I got Lisp.
Now, I would like to preface what Scott's about to say by saying that I discovered that Lisp is used a lot in terms of writing audio processing things.
Yes.
So I started looking into Lisp because I don't program much, if ever.
Mm-hmm.
Good God.
Right. But Lisp, the word Lisp, the reason it's called Lisp is because the list processing language, you see. And basically, I call them the parentheses languages because it's all parentheses all over the place. Like you'll do a parenthesis, something, comma, something, comma, something. You got a list. Then you'll put like some name of a function, like pop, push. I forget what the words are because I used Lisp once a long time ago.
Yeah.
It's like I know about it on paper, but I don't really know it because I don't use it for anything.
But like audio is an example, because I was looking into this. You want to process some audio, so it's like you've got a list of different different transformations or
it's like the shoulder and the cutter and the something like that, right?
But you've got like a list of different attributes of audio, and then you've got a list of different functions you want to apply based on different parameters.
Yeah. But anyway, the point is that Lisp is a language that is built around lists, right? So if you're thinking of solving a problem that involves lots of lists of things, right? Lisp, if you think about that problem in the Lisp language or try to, solve that problem with the Lisp programming language, that was sort of an ATM machine right there, Lisp programming language. It'll probably be really easy, and it probably won't take as many lines of code to do that, to solve that problem. For example, at least when I used AutoCAD way back in the day in like high school, right? Like it must have been AutoCAD 2000 or I think it was AutoCAD Release 14. The, AutoCAD, you control it with the GUI, clicking on buttons and then clicking on the screen to give the But you could also do all of AutoCAD from this little command line. And all the commands were very Lisp-like. I'm pretty sure it might have been Lisp powering the AutoCAD in those days. Because think about, what is AutoCAD? When you're creating, architectural diagrams, mechanical diagrams, blueprints, that sort of thing. It's lists of points, lists of coordinates, lists of vectors, and that's all it is. So Lisp is the perfect language to do that sort of thing. So people often ask, you're like, oh, what's the best language, for learning, or what's the best language for this, and what's the, is this language better than that language? And the answer is,
I want to use an analogy real quick. Is a hammer better than a screwdriver?
yeah. See, each language,
The answer is, of course, yes.
well, actually, there are some Lisp is not the only language of its kind. There are other languages that are similar to Lisp. For example, Scheme is very similar to Lisp, right? And so many people will argue that, Scheme is better for learning than Lisp. And, there's different variations on the same theme. And, many times it won't matter which one you choose. Or maybe one has a few disadvantages and one has other advantages. Sort of like you go to the Home Depot, right? There's a whole bunch of hammers, but this one's a ball peen hammer. And this...
You just wanted to say ball peen. You've been wanting to say it since I said the word hammer. You've been obsessed with that word for the last...
Or like you'll go and there'll be a Phillips screwdriver and a flathead screwdriver.
Wait a minute. Wait a minute.
They're both screwdrivers, but they're a little bit different.
What about tack hammers?
Tack hammers are the best.
Okay.
But anyway, so a programming language is much like that. But sometimes there is one that is just better than the other. For example, actually, I can't think of a terrible language right now. I'll try to remember.
Well, you know what? In terms of doing something useful, QBasic, not so useful.
Yeah, that there are languages that are sometimes, they're the same kind of language, they're suited to solving the same kind of problem, but one is just better than the other. For example, a plastic toy hammer, a big metal hammer. One is just better than the other.
Well, Mjolnir.
Yeah, exactly.
Or Mjolnir, I don't know how to say it.
They both solve the same kind of problem. That one doesn't really do anything the other one doesn't do, but one is just better at that, so one of them is kind of useless. But, when it comes to comparing something like C and something like Java, they're not really comparable. I mean, if you have a problem in mind, like this is my problem, which language is best for solving this problem, then I can give you an answer, because I can say, well, this language, the advantages of this language will mean that you can solve that problem much easier, or get these advantages and such and such.
I can give one opinion, though. I think for people who don't know more about this topic, or kind of are listening to Scott to learn about CS but don't really code, or just you're new to all this, I think I would, in the end, recommend Python.
Well, here's the thing, all right? Here, I'll start talking about what certain languages are good for, right? We'll start with Python because it's a very popular recent choice, right? Python is a language that is really, it's an object-oriented language. I don't know, I'm not going to talk about, maybe I'll talk about what that means. But it's an object-oriented language, and pretty much for most modern programming for the web and for desktop applications, object-oriented, when it first came out, they thought it was a fad, but no, it's the real deal. Object-oriented pretty much is the way a lot of programming is done these days. Because thinking in an object-oriented manner seems to be very good for solving a great many common computer problems, and even if it's not the optimal way of solving your particular problem, it's usually a very good way.
Yeah, I think the example I was given by a professor early on at RIT was he showed Quake, and he talked a little bit about programming languages while Quake just played in the background.
I think I was there.
Yeah, you might have been. And then he basically said, all right, now, because, we were all techie people a little bit, we were punk kids, and most of us knew some procedural programming, like BASIC or something, and it was like, how would you make Quake in a procedural language? And we were like, and he's like, it's not impossible, but it's effectively impossible.
Yep, because a procedure, I'll start talking about this then, right? A procedural language, right? And in many ways, all languages are sort of procedural or have procedural aspects to them. But a procedural language is pretty much sort of just easier assembly. Assembly says do this, then do this, then do this, then go over here and do something different, then go back over here and do what you were doing again. It's here the order to do things, and sometimes it can repeat things it does, which it will often do.
It might go and do something else that it can go and do a bunch of times. Go sub.
Yep, it'll do all sorts. It's programming by procedure. It's like, here are the things to do in order. If you want to build a house, first pour the foundation, then set up the frame, then, put on the roof. I don't know how to build a house, obviously.
But then, I mean, there's some problems there. And what if you want to build 10 houses?
Yeah, well, it's not just do you want to build 10 houses, because building 10 houses is easy. It's follow the instructions of building a house 10 times.
Well, yeah.
But what if you want to, to have, red houses, blue houses, and green houses? Well, we can still do that with the procedural language.
Yeah, but it gets more and more complicated.
Well, you want townhouses, and then you want to build houses on different streets, and you want to have people in the houses, and you have furniture in the houses.
Or you're going to build a lot of houses.
You want to have people walking around the houses, and you also want to program the construction workers.
But different houses have different attributes.
And you want the prices of the houses, and...
Like, all the houses are different, but they're all based on, like, a same basic house, just everyone wants some custom stuff.
This is where you get object-oriented programming, in which the thinking behind object-oriented programming is you define a bunch of classes, right? And a class, an instance of a class is an object. So I'll have the class house, and one instance of the class house is an actual house. And I can write the class house to sort of describe. Writing the class house is sort of like saying houses are like this.
I have to interrupt you.
Why?
People who live in class houses shouldn't throw exceptions.
That's bad.
I'm sorry.
So I could also write a class car, and I basically, when I write the class car in code, I'm saying cars are like this. They have these properties, and cars can do these things. A car has a color, it has a horsepower, it has a size, it has a weight, it can drive, it can stop, it can honk its horn, I define sort of what a car is like. Then I define specific cars. I say new car Ferrari. It's red. It has 400 horsepower. It goes really fast. Its horn sounds like this. And then I say Ferrari go drive, and then the Ferrari will drive. And then I can be like new car, drive, stop. And I can make all these cars start doing all these things. Just defining what a car is like, then making cars, and then changing the properties of the cars and invoking the things that the cars can do. And it's thinking about solving problems in that way, you can solve a lot of problems that way. I mean, let's try to think of a real problem you would solve that way. Like a video game, right? Enemy, I make the enemy class. The enemy has these many hit points, and he can, these are his attacks. Right? The good guy, he has these many hit points, he does these many attacks. The map is this long, it has this many things in it. Then, after I make all these classes, I describe what enemies and good guys and maps are like. I then just say, new map, put in the map 10 enemies, put in the map 1 instance of the good guy, and map go. And then you have a game.
And, you can just loop through and have them all, things will call things.
You don't even need to loop through. You just, say everything start, and then the things will go. Yeah. But if you program properly with threads and such.
I'm not, and will likely never be at the point where I will program with threads.
It's not that hard.
Yeah, but I'm not.
Anyway.
I make a bunch of objects, and then I loop through them, calling some sort of timing thing that tells them all to do their shit.
Yeah, see, you take... See, that's a very common way to program things, is to use an object-oriented data model, but to use an actual, procedure wrapped around that, as opposed to just using, some sort of functional, non-object-oriented, data structures, just like some linked lists and some arrays.
And I'll admit straight up that the main reason, I do things like that, and a lot of people do, is because the object-orientedness of setting it up makes it very easy to put everything together. And then coding the other part is very easy.
Yep.
So between the two, it takes a lot less good programming practices.
Yeah, so a programming language, the reason we have so many of them is because each of them allows you to think in a different way to help you solve different kinds of problems. And you really want to pick the language that lets you think in a way that is conducive to solving the problem at hand. Should I keep talking?
I don't know.
I'll keep talking some. So let's just go over, I'm going to be real brief and talk about the most popular languages.
That's a good thing to end
quick.
on. Not talking about some specific languages would be pretty sad, and people would not be happy, I think.
So C is a pretty popular language. It's not object-oriented. It's a functional procedural language, and it's mostly good for doing things like device drivers and programs that might have to run on your microwave or stuff like that. What C is really good at, is it's very close to assembly. You know, there's a compiler for C for pretty much any piece of hardware out there. So you can do really low-level stuff, but you don't have to write assembly. You can write C, which is a little bit easier, a lot easier. You know, or you can mix C and assembly together a lot too. So it makes writing that sort of close to the hardware program a lot easier. Now, before, a long time ago, C used to be it. And for a lot of things, C is still it because, you know, even though it might be harder to write something big, you know, like a game or like a big 3D game in C, if you do write it in C, because you're so close to the hardware, you can do lots of optimizations and get a really high performance. So if you need high performance, C is also a good way to go. But there's also C++. C++ is pretty much a lot like C, but it's got object-oriented action going on. Objective-C is also similar to that. The thing about C++ is that I really don't like the syntax. It's pretty painful. It's you know, writing in C++ is not a joy. But it has advantages in that, like C, you can compile it for anything. You can actually still get really close to the hardware like in C. But it's object-oriented, so you can actually think about a lot of problems in a more modern way, but also get high performance. And that's why a lot of games are written in C++, because they get the high performance, but they can still think about the game in an object-oriented way, and it won't be so hard to make a game as it would be to make the game in straight C like they did in the olden days. Let's see what else we got here. Here. Visual Basic, right? Visual Basic is a programming language, but it comes with sort of like this GUI making thing for Microsoft, you know, the Visual Studio whatnots. And pretty much what it's good for is if you need a Windows-only program or want to run it in Wine or something, that's pretty simple, but is mostly just a GUI, you know, a Windows GUI with buttons and labels and images and, you know, nothing fancy. You can whip it up in Visual Basic really quickly. It's a Visual Basic, you know, you make a visual thing that's very basic, and you can make it mostly by clicking on things without very little code at all. That's what Visual Basic is all about.
But at the same time, don't underestimate it. Visual Basic and the related, you know, Microsofty things are very powerful for doing certain things.
Yeah, I mean, if you want to make like a little GUI that helps people generate like spreadsheets in Excel in a little format, Visual Basic is where it's at, you know? Let's see what else I can think of. All right, Java, right? Java is very object-oriented, like super object-oriented, right? But the advantage of Java is that, first of all, there is Java libraries for pretty much everything in the universe. So if you want to, you know, do like encryption, you don't have to write a whole new encryption thing. There's a Java encryption thing that you just use. It's already there for you. You can actually, you know, you can add some features to it if you need to. If you want to do graphics, there's already a Java graphics thing. You just take it and use it. You know, they already wrote the classes. You just got to use them in your program. It's beautiful. The thing about Java is that you're not going to get the highest performance. Java's a lot better with performance than it used to be, but it's not the highest performance. The advantage of Java is that Java runs in a virtual machine, sort of like VMware, but not quite. So you write a program in Java, now that program runs on any machine that can run a Java virtual machine. You write the program once, you can put it on any machine that has Java, from a cell phone to a supercomputer. Right? C, you have to sort of rewrite your program for every different chip because you're writing so close to the hardware, you know, that you got to recompile the program for different machines, and sometimes you might even have to change the code in addition to recompiling. So that's the advantage of Java. Java's actually, you know, a lot of people put down Java applets, you know, and they should put down Java applets because that's really where Flash is the winner. But Java really is the winner. Go look at Puzzle Pirates. Puzzle Pirates is written in Java. A lot of cell phone games are written in Java. Yahoo games, a lot of those are written in Java. And that's, you know, Java's really good at that. It's also really good at a lot of other things that you may not realize Java's being used. Because a lot of people just sort of associate Java with Java applet. But, you know, a lot of web servers run Java. You don't even realize. It's also good for like enterprise database stuff because it's so, you know, robust. You can just also bump up new virtual machines all over the place. You know, you get the advantages of like a VMware without actually having to do a VMware.
Yep. I mean, a lot of like big e-commerce website thing solutions are using Java stuff integrated with some sort of crazy web sphere.
Yep. Let's see. What are the major languages? All right. I'll talk about PHP. PHP, I don't know. I'm trying to think of something to call it, like piece of shit something, but PHP started out way back in the day when people had like GeoCities, right? And they could only make HTML, and that was it, static HTML. But they wanted to put stuff on their websites, like little counters and other dynamic things, things on a web page that weren't static. And basically, PHP started out as like, hey, put this little bit of code on your website and I'll put a counter there. Or put this little bit of code on your website and an animated thing will appear. And people did that. And it was like, oh, man. And then PHP somehow expanded into being a full-on programming language. PHP is kind of useful in that you can use it as like, a scripting language, just like for doing normal like operating system stuff. You can use it to sort of make really easy, websites that are dynamic because you can mix it in with the HTML. You can like write some HTML, then a bit of PHP, then a bit of HTML, then a bit of PHP. So you can sort of put dynamic things in the middle of the web page. So if you're good at HTML, it's not that hard to do PHP also, and it's really, you don't have to really program it, even though if you want to, you could take PHP and go full on object-oriented awesomeness all the way. It's totally crazy like that. But it's not so advanced, and it actually leaves you with a lot of trouble where if you actually try to make something big and crazy, you'll often fall short with PHP and you'll run into a lot of problems and such. And it's actually pretty tied to like the web server in many ways, and it can cause a lot of trouble there, right?
Talk a little bit about Perl.
I'll tell you about Perl. Perl, the philosophy. See, the other thing is that a lot of languages will be similar to each other, but the philosophies will be different. And Perl is the great example of a language where what it does is just fine, but the philosophy is one that is basically the opposite of the Python philosophy, right? Perl and Python, in terms of what you can do with them, are pretty similar. I mean, it can both, they're both for web pages. They can both, make actual applications in them. They're both sort of higher level languages. There's quite a bit of similarity going on. The thing is, the philosophy of Perl is that there's a million ways to do everything, and there's all these sort of syntactical shortcuts and things. So it's like, you could write a Perl program, and I could write one. They do the same exact thing, but yours looks nothing like mine, Yeah,
Perl is also the language where a lot of people learn what regular expressions are.
Yep. Perl is very good at processing text. You have some text, and you want to do something with it. You want to read it, or you want to turn it into some other text. Perl is awesome at that, right? Because it's very closely tied with the regular expressions. Python does all the same stuff as Perl, except Python philosophy is there should only be one way to do it. If I write a Python program to do X and you write a Python program to do X, they should look exactly the same. There shouldn't be another way to do it. There's sort of a right answer, or a theoretical right answer. Like, this is the way that this program should be written.
Python, I found Python to be very intuitive.
It a lot of language. The thing is, you probably haven't used a lot of the other also intuitive languages.
No, I haven't, but I've used Perl and Python, and
Perl isn't that intuitive, but
No, it's not.
Ruby is just as intuitive as Python is.
I never actually tried to use Ruby. So.
A lot of the things will look very similar to Python. Just sort of variable equals this. If this then that. Sort of. The typical, very easy to understand sort of stuff.
Yeah. There's brain fuck.
No, but brain fuck, yeah. That's just see, brain fuck is just sort of a joke language. It's not really useful for anything except for teaching.
But at the same time, you can learn a lot from it, because if you are able to write something moderately complex in it, you've learned a lot.
Yeah. It's really, yeah. There's a lot of languages out there that are sort of toy languages. Like, they make them not for the purpose of actually doing anything really useful for the real world, even though you might be able to, but sort of, as sort of like exercise. Like, you look at the language and you think about it, and then, your mind sort of expands thinking about that, and now you're better at dealing with other languages and such. And brainfuck and white space, and
I was about to bring up white space.
They're all good examples of that.
Because I just realized that the Wikipedia page on whitespace is fantastic.
Yeah. Here's a language you probably may not have heard of that I sort of learned once, called Prolog, right? And Prolog, as the name sort of implies, is a very logical language. You ever do those problems in the puzzle books that are like, there are 5 people and 5 items. Joe doesn't have the red item. Mary has the blue item. He has the item that's darker than that one but lighter than the other one. That sort of thing. And you sort of put X's in the boxes to figure out who doesn't match and who does match with what, until you figure out who has what item and who lives in what house, and which item is in which house and all that business. Prolog is a lot like that. You sort of say, okay, there's this thing. this thing, and you sort of set up these rules, like you set up the circumstance, like, okay, this can equal either this, or this. This can never be equal to that, and this is one of these three. And then Prolog just sort of sorts it out and arrives at an answer. So it's very good at solving logic-type problems where you have associations of things and some sort of set of logical rules, and you want to see like the sort of the set of all the possible answers. Like if you're doing some discrete maths, Prolog is the way to go, because it'll just be like, oh, that's your situation. These are all the possible true things that will fit that, you know? I'm gonna try to wrap it up here.
We probably should.
Yeah. You gotta pick a language that I haven't talked about that's probably pretty big.
I don't know. I mean, all I write in is Perl, Python, and Bash scripts.
I didn't actually talk about Python, even though I've mentioned it 100 times. Python is basically the thing about Python.
You did talk about Python.
I sort of talked about it.
What else are you gonna say?
The thing about Python that you have to know about is that, first of all, unlike a lot of other languages where indentation is really sort of a thing to help you read. Like, you can write in C and not indent, and it won't care. But, you're supposed to indent because it makes it easier to read and makes it easier for people to understand.
Yeah, by indenting, we mean, like, say I have a for loop or a while loop or something. I indent everything underneath that in the loop so it kind of stands out as being grouped together under the loop.
Yeah,
it makes it easier to read.
It makes it easier to read the program and figure out how it works. Python forces you to indent. Like, it actually looks at, when the Python interpreter runs and looks at your code, it looks at the indentations and is like, hey, that indentation doesn't make sense. Or, okay, that's indented one down from this, therefore I should do this. Indentation actually matters in Python. But Python's a really useful language because, on the one hand, right, it's a very high-level object-oriented language with a lot of power and a lot of shortcuts to make, everyday, programs and scripts very easy. It has an interpreter, so you can just sort of type in Python code and it will happen immediately to sort of test things out. Like if you have a class you wrote, you don't actually have to write some, script to test the class out. You just type Python, you import the class, and then you sort of make objects in the class, and you can just sort of, you can be like, oh, I'll make a car, and the car is made immediately. And you'd be like, okay, drive car, and you can watch the car drive, and you can see if things are working and how they work, and that's why it's very useful for learning and testing. But Python also is very strange in that it sort of compiles into C, sort of. So a lot of people nowadays, like when they're writing games, like a big game that has to be like, very high performance, 3D game, need a lot of frame rates, right? They'll write it in Python because it's very easy to think about, doesn't take very long. But then they'll convert the parts that are low performance, like, oh, this part's really slow here, the part where it renders the bad guy. So they'll convert it to C, they'll rewrite all that code to make it fast, but the rest of the code is still Python, but it's all good because you just import the C library into the Python. It doesn't care. There's a little Python wrapper around it or whatever you need to do. And you can make really high-performance applications without having to write everything in C. You can think about things in the Python way and only rewrite the slow parts in C. You see? Python has a whole lot of other advantages besides that, like, a lot of frameworks. There's modules for pretty much everything you could want. Like if you want to, do this, well, there's a Python, it's sort of like Java. Python also has a module for everything. You just have to find that module and import it and read the documentation for how it works. And yeah, it's generally pretty useful for a whole lot of things. Yeah. I'll probably talk about more languages again later. I gotta figure out what I'm gonna talk about next.
Well, pretty much. I mean, I'm gonna do one more, and then we're gonna go back for a little while, maybe a couple of weeks probably, to normal Monday night shows.
So I got like a month to figure out what I'm gonna talk about in the next.
One thing I like to end on though is I think I was poking around the list on Esoteric or Esolang. It's a wiki of esoteric programming languages.
That's the word I was looking for.
And I think I discovered my favorite programming language ever.
All right, what is it, RIM?
It is called IRP.
All right.
Internet Relay Programming. I will leave it to you to read how IRP works. This has been Geeknights with Rim and Scott. Special thanks to DJ Pretzel for the opening music.
Be sure to visit our website at www.frontrowcrew.com, where you'll find show notes, links, our awesome forum, a link to our Frapper map, and links to all the RSS feeds.
We say feeds plural because Geeknights airs 4 nights a week, covering 4 different brands of geekery. Mondays are science and technology. Tuesdays, we have video games, board games, and RPGs. Wednesdays are anime, manga, comic nights. And Thursdays are the catch-alls for various rants and tomfoolery.
You can send us feedback by email to geeknights@frontrowcrew.com. Or you can send audio feedback via Audio. Just click the link that says Send Me an Audio on the right side of our website.
If you like what you hear, you can catch the last 100 episodes in iTunes or in your favorite podcatcher. For the complete archives, visit the website, which has everything.
Geeknights is distributed under a Creative Commons Attribution Non-Commercial Share-alike 2.5 license. This means you can do whatever you want with it as long as you give us credit, don't make money, and share it in kind. Geeknights is recorded live with no studio and no audience. But unlike those other late shows, it's actually recorded at night.